Hello everyone. In this session, I will continue with the Laplace transform of unit step function and the second shift theorems. The Laplace transform of unit step function, unit step t minus a is given by exponent minus as divided by s. Whereas for the second shift theorems is if a more than 0 and Laplace transform of the ft is fs, then the Laplace transform of the ft minus a unit step t minus a is equal to the exponent minus as Laplace transform of the ft, or we can say that it's the exponent negative as fs. Now let's look at the example. Find the Laplace transform by using the second shift theorems. Laplace transform of the ft is equal to the Laplace transform of the t squared plus Laplace transform of the 4t minus t squared unit step t minus 4. So this is the question. Laplace transform of t squared plus Laplace transform of 4t minus t squared and then unit step t minus 4. So in this part, we need to expand, we need to change it a bit according to the second shift theorems. So 4t minus t squared, we can change it to 4. Okay, we have the unit step t minus 4. Therefore, we want to change it same to the t minus 4. So we have 4 and then in the bracket t minus 4. But this t minus 4, the minus 4 is the extra. So we need to cancel out by add the 4. And then minus the second part, t squared. So this 4t already settled here. And then t squared, so we have a minus, so we can make it like minus t minus 4 plus 4 squared. So this minus 4 plus 4 actually can cancel out and we still left the value is t squared. So we can take it out. This is equal to 4t minus 4 because we want t minus 4. So 4t and 4t minus 4. 4 and then in the bracket t minus 4 and then this one we get 16. So we have plus 16. Then minus with t minus 4 square. But if you look at t minus 4 square, t minus 4 square, we have a different value. Okay, I write it here, t minus 4, actually, t minus 4 square is actually equal to t square minus 8t plus 16. Okay, plus 16. But this minus 8t plus 16 is an extra. We don't need this one. So we need to plus with 8t to cancel out. And then if you look at the original question here, we have what we have here. If you multiply, we have what we have 4 times 4 square, you have 16. So we already have the 16 here. We already have the 16. So and here also have 16. 16 plus 16 is 32. So this 32 is an extra. So we need to minus 32. Therefore, so we need to plus with add t minus 4. So this one is actually the same. For add t minus 34 and minus 32, and then plus with 16. If we calculate back, are you able to get back the same value as this one? Okay, let's check. If you have t minus 4 square, that is equivalent to t square minus 8t plus 60. Okay, and then this one is plus 8t minus 32. Okay, and then plus with 16 for this one. So do you think you can get back the t square? Okay, this one and this one can cancel out. 16 minus 32, you get negative 16 plus 16, so you can cancel out also. So you can get back this value. So I write it here is equal to negative. So this part 4t minus 4 in the bracket t minus 4 plus, okay, this one. So it's a minus. So you have minus And then this one you have minus t minus 4 square, and this part minus this part you have minus 4t minus 4. 16 and 16 we can cancel out. So this is basically this part only for here. Okay, so I rewrite here that is Laplace transform of the ft is equal to 2 over, okay, Laplace transform of t square you get 2 over s power of 3, and then plus with Laplace transform of minus t minus 4 square minus 4 t minus 4, then ut minus 4. So this is equivalent to 2 over s power of 3 minus Laplace transform of t minus 4 square, and then we separate, okay, we separate the equation, so you have the ut minus 4, and then minus, okay, with 4 Laplace transform of t minus 4 ut minus 4. That is this second part. So this is equivalent to 2 over s power 3 minus, so this part we can apply the second shift theorem. So what is the second shift theorem? Do you still remember? The second shift theorem said that Laplace transform of the u t minus a ft minus a unit step t minus a is equivalent to exponent power minus as, then Laplace transform of the ft. So therefore, this part we can change to exponent negative 4s, then Laplace transform of, okay, Laplace transform of this t square. Now we change to t square minus 4. So for this part also the same, exponent negative 4s Laplace transform of t. So this will equivalent to 2 over s power 3 minus 2 exponent negative 4s divided by s power 3 minus 4 exponent minus 4s divided by, okay, Laplace transform of t is s squared. Okay, that is how we use the second shift theorems to solve this question. Next, we move to another question. That is the Laplace transform of the pt equal to the 2 Laplace transform of 1 plus Laplace transform of t minus 2 and the unit step t minus 3 plus Laplace transform of 1 minus t and then unit step t minus 5. Okay, in this question, 2 Laplace transform of 1 we can get 2 over s, and then Laplace transform of t minus 2 unit step t minus 3. So again, we need to make it same. Okay, for example, t minus 3, here also we need to make it t minus 3. So we have, we can do it like this, Laplace transform of t minus 3, and then how to get minus 2, t minus 2, same value. So we need to plus 1. So t minus 3 plus 1 still remain t minus 2. Then unit step t minus 3 plus Laplace transform of minus, okay, we need to same, make it same, this value make it same as t minus 5. So again, we have the minus t, right? So we take out the minus, and then t minus 5, okay, t minus 5 plus 1, plus 4. Because if you have multiplied in, we have the minus t, and then minus 5 plus 4, you get minus 1. Minus 1 multiply with negative, you have positive 1, which is same as this value. And then this is equal to 2 over s plus Laplace transform of, okay, we need to split this one. So we have t minus 3 unit step t minus, we need to split these two. So Laplace transform of t minus 3 unit step t minus 3. So this one and this one, we need to split it. So plus with Laplace transform of unit step t minus 3. Okay, then minus, okay, we take out the negative, so it's minus. This one also same. This one multiply with this one plus 4 multiply with this one. So minus Laplace transform of t minus 5 unit step t minus 5 minus 4 Laplace transform of unit step t minus 5. So this is equivalent to 2 over s plus, okay, from here, this is, we can use the second shift property. You still remember second shift property? Okay, I write it here, second shift property. Okay, this is the second shift property, and if we check, if we compare with this equation, so we have Laplace transform of f t minus a u t minus a. So this is Laplace transform of t minus 3 u t minus 3. So our a is 3. So we get exponent negative 3s. Then Laplace transform of the ft. Ft is referred to this one already can move out, right? So we left t only. So we have exponent negative 3s Laplace transform of t plus, okay, this part is the Laplace transform of unit step function. Okay, Laplace unit transform or Laplace transform is Laplace transform of u t minus a. We can get exponent negative as over s. So therefore, here we can get exponent. The a here is 3. So exponent negative 3s over s. And this part we get minus exponent negative 5s Laplace transform of t. And then minus with the last part, you have 4 exponent negative 5s divided by s. Then now we can simplify. You have 2 over s plus exponent negative 3s over, okay, this is Laplace transform of t. You still remember from the table of Laplace transform? Laplace transform of t, we can get 1 over s squared. And then plus, we copy down this one, exponent negative 3s over s. And then for this part is negative exponent negative 5s. Okay, Laplace transform of t, you get 1 over s squared. Okay. Next, we look at another example, that is change the following step function to unit step function, then find its Laplace transform. There are 4 steps in finding the Laplace transform using the second shift theorems. So first of all is write down its step function. Then second, change the step function to a unit step function by using this g1 plus g2 minus g1 and unit step t minus a. So this one, we use this one. Then the step number 3, we assume the t minus a units t minus a, and then apply the second shift theorem and get the Laplace transform. So first of all, if we look at this step function, we can change to unit step function. That is, okay, from here we can see that 1 minus sine t. So we write down 1 minus sine t, and then plus with the second one minus the first one. So that is the cos t minus with 1 minus sine t. And then multiply with unit step t minus 2 pi. The value 2 pi is based on the value here. Okay, then Laplace transform of the ht. You get Laplace transform of 1, and then minus with Laplace transform of the sine t plus Laplace transform of the cos t. Here we can split it, okay? We split into 3. Okay, we split into 3. This is 1, this is 2, this is 3. We split into 3. So Laplace transform of the cos t unit step t minus 2 pi. And then minus Laplace transform of unit step t minus 2 pi. That is referred to this one, minus 1. And then last one is the plus sign. Okay, plus with Laplace transform of the sine t unit step t minus 2 pi. So Laplace transform of 1, you get 1 over s. And then Laplace transform of the sine t, you get 1 over s squared plus 1. And then plus with Laplace transform of the cos t unit step t minus 2 pi. So this one we need to change to Laplace transform of the cos t minus 2 pi unit step t minus 2 pi. Okay, and then minus with Laplace transform. Okay, this one Laplace transform unit step t minus 2 pi. We can change it. We can change into Laplace exponent minus 2 pi s over s. So this is referred to the property Laplace transform of the unit step t minus 2 pi. You get exponent minus 2 pi s over s. Okay, so we change using this one, this property, and then plus with, last one is the Laplace transform of the sine t minus 2 pi. We need to make it same. And then unit step t minus 2 pi. Okay, next step. So 1 over s, we simplify, minus 1 over s squared plus 1. Okay, and this part, we can change it using the second shift theorems. This is the exponent minus 2 pi s Laplace transform of the cos t. Okay, this is exponent 2 pi s Laplace multiplied with Laplace transform of the cos t. Here, please take note that Laplace cos t equal to the cos t minus 2 pi. This means that the cos t is equivalent to the cos t minus 2 pi. So that's why we don't have the plus or minus something. And whereas sine t is equal to a sine t minus 2 pi. Okay, then we continue. Okay, after you obtain cos, then this one is minus exponent negative 2 pi s over s plus with this one. The last one is the exponent negative 2 pi s Laplace transform of the sine t. So this is the second shift theorems. And then we simplify, and then we get 1 over s minus 1 over s squared plus 1 plus with exponent negative 2 pi s Laplace transform of cos t, you obtain s over s squared plus 1. And then minus with exponent negative 2 pi s over s plus with exponent negative 2 pi s. For the Laplace transform of sine t, you get 1 over s squared plus 1. So at the end, you simplify it, you get, you can simplify this one and this one together. So 1 minus exponent negative 2 pi s over s plus with this one and this one. So you get s exponent negative 2 pi s plus, this one also, exponent negative 2 pi s minus 1 divided by s squared plus 1. So that's all for this question, and that's all how to find the question or solve the question using second shift theorems and also the step function, unit step function. And then second question, you have the line here. Okay, you have the line here. gradient line here, and also you have the unit step here. So what is the value? What is the value of this? So this one is equal to 2t. Okay, this one is equal to 2t. Okay, if you don't know how to find the function of this line, this gradient line, so we can find it together by find the coordinate first. So this coordinate is referred to 0 and 0, and this coordinate is referred to 3 and 6. So we have two coordinates. So first of all, we need to find the m, okay, where the gradient is equal to y2 minus y1 divided by x2 minus x1. So this is referred to 6 minus 0 divided by 3 minus 0. This is equivalent to 2. The m is equal to 2. And then we need to find the equation. Y equal to mx plus c. So we simply take one value. Okay. And we know that actually we don't need to count this one because we know that the c is passed through at the origin. Cross at origin. Okay, if you want to find, also can. So let's say I want to find the y. Okay, y I assume that is 0 because we use the coordinate 0, 0, 0. And then m is equal to, and then the x is 0 and c. So what is the c value? C is 0. So I said no need to find because it will cross at 0. And then we need to know the function. So we still need this formula y equal to mx plus c, and we simply substitute in one equation. So y equal to we simply insert the gradient m, so 2x plus c is 0. So y equal to 2x. So this line is 2x. So in this question, you use a t instead of x, so it's 2t. Okay, 2t. So that is how I get the ft equal to 2t, which is from 0 to 3, and then the another one is minus 1, right? This is minus 1 starting from t more than 3, more than or equal to 3. So I write the step function in this way. Okay, now we have a step function like this. So what is the unit step function? You still remember using the formula? So first of all, we have the 2t. So we start with 2t plus with, okay, the second one minus with the first one. So that is minus 1 minus with 2t, and then multiply with unit step t minus 3. Okay, so this is the unit step function. Now we want to find the Laplace transform of the ft. That is Laplace transform of 2t minus Laplace transform of 1 plus 2t. Okay, we take out the minus, so 1 plus 2t. And then unit step t minus 3. Okay. Again, as you know, we need to change this because unit step t minus 3. So we need to change this one. So I said that need to change to t minus 3 form. So this means 1 plus 2t, you need to change. So I change to 1 plus 2, and then t must be t minus 3. So t minus 3. Okay, now what is the value? So now I have the 2t minus 6. Okay, 1 plus 2t minus 6. At original, the question is 1 plus 2t only. This minus 6 is an extra, so I need to cancel out by plus 6. So I simplify, I get 7 plus 2t minus 3. Okay, so therefore, we continue again with, okay, Laplace transform of 2t, I take out the 2, it is a constant. Laplace transform of t, I get 1 over s squared minus Laplace transform of, okay, these whole things, 7 plus 2t minus 3, unit step t minus 3. So this is equivalent to 2 over s squared minus 7 is the constant. I take out the constant. So this one I can split because this is a operation of plus, so I can split into 2. So Laplace transform or unit step t minus 3 minus with 2 is a constant. Again I take out, and then t minus 3 multiply unit step t minus 3. So this is equivalent to 2 over s squared minus 7. Okay, this unit step t minus 3, again you can change it to exponent negative 3s over s. Okay, and then this one is the second shift theorems. I can change to 2. This one is 2 is a constant, so I change to exponent negative 3s. Then Laplace transform of t. So this will equivalent to 2 over s squared minus 7 exponent minus 3s over s minus 2 exponent negative 3s. Laplace transform of t is equal to 1 over s squared. Okay. So that's all for this question. Next is about the second shift theorems for the inverse Laplace transform. Okay, we use the second shift theorem to solve the inverse Laplace transform. So this is the second shift theorems. It's the same like I showed you before. And this is the step in finding the inverse Laplace transform using the second shift theorems. So we need to follow this step. So first of all, we need to make sure the expression is in the form of the exponent divided by the polynomial. And the first step is determine the value of a. Then second step, write down the function of fx. Then find the ft. Then the fourth step is to change the variable from the t to t minus a for a function ft. Then last step to evaluate the inverse Laplace transform. Now let's look at the example. Evaluate the inverse Laplace transform of the following expression by the second shift theorems. Write down the answer in the form of step function and sketch its graph. Okay, from this question we can inverse Laplace transform or separately inverse Laplace transform for each one. So we take out the 2, then inverse Laplace transform of 1 over s minus 3. Again is a constant, then inverse Laplace transform of exponent minus s over s plus 4 inverse Laplace transform of exponent minus 3s over s squared. And then we use the second shift theorems. Then we follow the step like the formula I showed you just now. Then make sure the expression is in the form of the exponent over polynomial. What is mean by exponent over polynomial means, okay, like this. This one is the exponent over polynomial. This one also the same. This is exponent over the polynomial. So we must make sure it's in this form. Then only we can use the second order shift theorems. So first of all, we look for the exponent negative s over s. This one. Okay, we look for this one. So the first step, okay, we follow the 5 steps. So the first step is find the a. So what is the a here? A is referred to this one. Okay. If you compare to the second shift theorems. So this is the second order shift theorems. If you look at the exponent s over s, and we want to look for the inverse, so we know that this is the inverse. So exponent negative s over s. So a is referred to 1. Then step 2, fs is referred to fs of is equal to 1 over s. Fs of a is equal to 1 over s. Next, you want to find the ft. Okay, ft from the fs is equal to 1. And then step 4, change the variable from t to t minus a for the function of ft. So ft minus a equal to 1. Then step number 5, is to evaluate the inverse Laplace transform of the exponent negative as fs. So this is equal to ft minus a ut minus a. So this is equivalent to inverse Laplace transform exponent s divided by s equal to 1. So ft minus a is equal to 1. Then multiply with ut minus a. A is equal to 1. So this is basically for the exponent negative s divided by s. Now we check for the exponent negative 3s over s squared. So step 1, we have the a equal to 3. Okay, this refer to this, a equal to 3. Then step 2, fs of this, we obtain 1 over s square. Fs of this is 1 over square. Then step number 3, ft from the fs is t. Okay, for the table of Laplace transform, 1 over s squared is equal to t. And then step number 4, we change the t to t minus a. So ft minus a equal to t minus a. So it's t minus a is 3. So step number 5, that is the inverse Laplace transform of the exponent negative 3s divided by s squared equal to t minus 3. Okay, this one t minus 3 multiply with ut minus 3. So here we can conclude that inverse Laplace transform of the 2 over s. So this is obtained from the question, okay? Because now we have settled this one, so we can put it in the place. So 2 over s, okay, 2 over s minus with 3, okay, minus with 3 inverse this one. Okay, 3 inverse this one, we obtain 1 unit step t minus 1. So here we write down 3, then unit step 3 minus 1, and then plus with, we go back to the question, with 4 inverse this value. Okay, this value is equal to, here, t minus 3, ut minus 3. So we have 4, t minus 3, unit step 3, t minus 3. Okay, so that's all using the second shift theorems for the inverse Laplace transform. Or you want to use another method, or we can say that it's a shortcut, also can. So this means that from the question is inverse Laplace transform of 2 over s minus 3 exponent negative s over s plus 4 exponent negative 3s over s squared. Okay, so we split it separately. So 2 inverse Laplace transform of 1 over s minus 3 inverse Laplace of exponent negative s over s plus 4 inverse exponent negative 3s over s squared. So let's calculate for the inverse Laplace transform of the exponent s over s. We obtain inverse Laplace transform of 1 over s. Okay, that is equal to 1. Then we consider the exponent negative s. Okay, so therefore for the inverse Laplace transform of exponent negative s over s, we can obtain is this one is the 1 unit step t minus 1. Okay, and then next is for the inverse Laplace transform of exponent negative 3s over s squared. So we obtain inverse Laplace transform of 1 over s squared is equal to t. Then inverse Laplace transform of exponent negative 3s over s squared is equal to t minus 3 unit step t minus 3. So if we combine, we will obtain 2 over s minus 3 exponent negative s over s plus 4 exponent negative 3s over s squared. So this is also equivalent to 2 minus 3 unit step t minus 1 plus 4 t minus 3 unit step t minus 3. So just now is the another option to find the inverse Laplace. So once we obtain the inverse Laplace, we can compare with the unit step function formula. So we compare with the g1 plus g2 minus g1 u t minus a1 minus g3 minus g2 u t minus a2. So this step is for you to convert from the unit step function to the step function. So g2 equal to 2 because the first one g2 equal to 2, and then g2 minus g1 we obtain minus 3. Okay, minus 3. And then g3 minus g2 is equal to 4 in the bracket t minus 3. So from here, g2 minus g1, you already know the g1 is equal to 2. So g2 is equal to negative 3 plus 2, that is equal to negative 1. Then g3 here is equal to 4 t minus 3 plus g2. g2 plus g2, g2 is equal to negative 1. So plus with negative 1, so we obtain 4t minus 13. So now we can write it in a step function. This means that here g1 is 2, g2 is negative 1, g3 is 4t minus 13. So now let's look at the limits. Okay, if we look at here, this one is ut minus 1. This means that the first one is 0 from t more than 0 and less than 1. And then the second one is from 1 to, okay, this is t equal to 3, so it means it's less than 3. The last one, of course, is t more than 3. Then we can, based on this step function, we can draw the graph. Okay, we can sketch a graph with 1 and 2. Okay, and then this one is 1, 2, 3. So from 0 to 1, we have the value of 2. And then from 1 to 3, we have the value of negative 1. And then from more than 3, we have the value of 4t minus 13. So 4t minus 13, again, you can write down when t equal to 3, what is the value? Okay, so 4t minus 13. So when t equal to 3, so yt equal to what? What is the value? So this yt is equal to negative 1 and t equal to 4, ft equal to 3. Okay, when t equal to 5, then ft equal to 7. So we can put it here. So when t equal to 3, y equal to negative 1. Okay, and then when t equal to 4, yt equal to 3. When t equal to 5, yt equal to 7. So maybe somewhere here, so we can put like this. Okay, so this is how you find the inverse Laplace transform. Okay, using the second shift theorems, and from the from the and in the step function to the unit step function. Last example is the inverse Laplace transform of the exponent 5s multiplied with 1 plus 2s over s squared. Okay, question B, we have the inverse Laplace transform of the exponent negative 5s 1 plus 2s divided by s squared. So step 1 is determine the value of a. So a here we have 5. A is equal to 5. Then step 2 is write down the function of fs. So fs is this part. So 1 plus 2s divided by s squared. Then step 3, we find the ft from the fs. So ft equal to the inverse Laplace transform of 1 over s squared plus 2, we take out the 2, so 2 inverse Laplace transform of 1 over s. So this is equivalent to t plus 2 only. And then step number 4, we change the variable from t to t minus a. So f t minus a equal to t minus 5, because t minus a is 5, so t minus 5 plus 2, so t minus 3. Then step 5 is evaluate the inverse Laplace transform of the exponent negative as fs. So inverse Laplace transform of exponent negative 5s, okay, so equal to t minus 3 multiply with the unit step t minus 5. T minus 5, this t minus 3, then multiply with unit step t minus 5. Because it's t minus a, right? T minus a is equal to 5. Okay, and then we compare with the g1 plus g2 minus g1, unit step t minus a1 plus g3 minus g2, unit step t minus a2. So again, g1 is equal to 0, we don't have anything. And then g2 minus g1, we only have this one, t minus 3. So g2 is equal to t minus 3 because g1 is 0. So now we can write the step function in which we have 0. And then if you look at here, it's t minus 5. So this means that is from 0 to 5. And then next one, g2 is t minus 3. So this is t more than equal to 5. So this is a step function. Then from the step function, we can draw or sketch the diagram. So we have value from 0 to 5. And then t minus 3, we have the value of, for t more than 5, we have the value of t minus 3. Okay, something like this. This is starting from 2. Okay, so that's all for this second shift theorems. Okay, hope you can understand. If you like my video, you can like my YouTube video. Thank you very much.